Hello students, the question is, two light identical springs of spring constant K are attached horizontally at the two ends of a uniform horizontal rod AB of length L and mass M. The rod is pivoted at the center O and can rotate freely in the horizontal plane. The rod is gently pushed through a small angle and released. The frequency of resulting oscillation is, the options are given. This is a JEE Main 2019 question. Date of exam was 12 January first half. So this is a very interesting question. Here we will learn about rotational SHM. Okay. Let's draw the diagram again. This is the situation. See, and this is the rod. The length of the rod is L, and these are the two springs. Initially the springs are unstretched. This is the center O. O is the point where the rod is pivoted, and AB is the two ends of the rod. Now this rod is, suppose it is rotated by small angle theta. Now why is the angle small? Because it is written in the question. See, the rod is gently pushed through a small angle, right? So this theta is very small. Now when the rod is rotated like this, then I can say that the two springs will be compressed like this, right? The two springs will be compressed. Compressed by what length? See, this is what? This is L by 2 and this is L by 2, right or wrong? Now from simple trigonometry I can say this angle is theta. So this is what? This is L by 2 cos theta and this is L by 2 sin theta, right students? Therefore I can say this is also L by 2 sin theta and this is L by 2 cos theta. Therefore I can say these two springs basically compressed by this length L by 2 sin theta, right or wrong? Since the two springs are compressed, they will push the rod like this. So if I draw the FBD of the rod, this is the rod, right? Now this spring will push this end of the rod by force K into X, and this spring will push this end by the same force Kx. Here of course X is what? L by 2 sin theta, right or wrong? Therefore two forces are there, Kx and Kx. These two forces will create a torque, right? As I mentioned earlier, this is theta, this is theta. So this length is L cos theta, right? Therefore I can say the torque acting, or you can say the restoring torque acting on the rod. Restoring torque acting on the rod will be minus, take any one force, Kx is any one force, into perpendicular distance. Perpendicular distance between these two lines is L cos theta. So minus Kx L cos theta. Here many students ask a question that why a negative sign is there. This is clearly due to restoring torque. Or I can say when the rod is rotated, it is rotated like this, that is clockwise direction, and see the torque which is exerted due to the spring is basically is trying to rotate the rod in the opposite direction. That's this. To show that opposite nature, we will put a negative sign in the restoring torque. So tau equals to minus Kx L cos theta. What is x? as I mentioned earlier, x is L by 2 sin theta. So minus k into L square by 2 sin theta into cos theta. This is the restoring torque acting on the rod. Now in the question it is given that this angle theta is very small, right? Let's write this. Tau equals to minus k L square by 2 sin theta into cos theta. See, now if theta is very small, I can write that sin theta tends to theta and cos theta tends to 1. Therefore tau will become minus k L square by 2 into theta, right? Now tau is what? Tau is I into alpha. We all know torque equals to I is what? I is moment of inertia, alpha is angular acceleration. So alpha equals to minus k L square by 2 into I into theta. Now we know for rotational SHM, not translational, rotational SHM, alpha can be expressed like minus omega square into theta. Omega is the angular frequency. Therefore comparing, I will get omega square equals to KL square by 2i. So omega equals to root over of KL square by 2i. Now coming to I is what? I is the moment of inertia of the rod AB about the center. Center is O, right or wrong? Because the rod is rotating about its center O, right? So what is the value? We all know, you have to remember the value. This is 1 by 12 into ml square. M is the mass of the rod. 1 by 12 into ml square. We have to put this value of I here. So omega equals to what? Root over of KL square by 2i. KL square by 2i. Let's put I equals to 1 by 12 ml square, right or wrong? So it becomes what? Root over 6k by m. This is the omega. Now they ask you in the question, find the frequency. We all know frequency n equals to omega by 2 pi. So the answer is 1 by 2 pi root over 6k by m. This is the formula of frequency of oscillation. See, look at the option, 1 by 2 pi root over 6k by m. So option 1 is correct. Option 1 is correct. Thank you for watching this video. Please subscribe my channel, Phi Solver.